Hello, welcome to my final physics video, and we are in Unit 11 of resistors in series and parallel. We will be calculating the equivalent resistance for a circuit of resistors in series, find the current in and potential across each resistor in the circuit. So I have my circuit drawn, and this circuit is in series since there are no junctions, and there are 4 resistors in the circuit and 9 volts going across the entire circuit. We have a resistance here of each of the resistors of 2, 4, 5, and 7 ohms. So, to first calculate the equivalent resistance, since it is series, we can just add them up. So, we can do our total is equivalent to 2 ohms plus 4 ohms plus 5 ohms plus 7 ohms. And we get a total of 18 ohms. We do that as our total resistance. So now that we have our total resistance, we can find our current across the circuit. So the equation we use is V equals IR, and we plug in our V, which is 9 volts. I, and then the resistance we just solved for. So we get that the current is equivalent to 0.5 amps throughout the circuit. So now we can go ahead and start on our current and potential across each individual resistor. So since it is in series, we know that the current is the same, like it's the same across each resistor. So we can go ahead up here and fill in our currents across each resistor. Okay, so now since we have our resistance and current, we can solve for the potential across each resistor. We get that the voltage drop across resistor 1 is 1 volt. And the voltage drop across resistor 2 is 2 volts. Our voltage drop across resistor 3 is 2.5 volts. And we get that the voltage drop across resistor 4 is equal to about 3.5 volts. So if you would like, we can double check and make sure our calculations are all correct. And we do that by adding up all the volts that we just got, and they should equal 9 if we did everything correctly. And they do. And so we did everything correctly. And that is a circuit in series and the resistors. Thank you for watching.